Hey everyone. In this episode of ITS Now, we will be looking at how our traffic systems in our busy urban areas need to develop in order to help to facilitate a greater uptake of active travel modes, the support that's required, the additional facilities to actually make it a better experience for users. I'm Alistair, and this is ITS Now. For some years, there's been a realization that the way in which the finite capacity is apportioned in our busy urban streets will need to be reviewed to cope with the ever-increasing demands put on them. There simply isn't sufficient space for everyone to use private vehicles. As a result, we have seen our streetscapes gradually evolving to benefit the increasing number of members of the public who are using active transport modes, such as walking and cycling. In London and other cities in the UK, parts of the road network have seen lanes being removed from use for mixed traffic and reallocated to provide additional capacity, typically for buses, cyclists and pedestrians. This also aligns with the change to the hierarchy of provision, which now emphasises the requirements for pedestrians, cyclists and public transport over mixed traffic. These schemes are often used as a catalyst to enhance streetscapes by using quality materials and taking the opportunity to incorporate trees and vegetation to improve the environment. It would seem counterintuitive that reducing the available space to mixed traffic can in fact increase overall capacity, but encouraging users to switch their mode of transport by providing quality infrastructure can indeed reap results. A single bike lane can transport many more people than a traffic lane, particularly during periods of congestion. In what would now appear to be an ongoing living with COVID era, some of the assumptions we have made over the past few years are now being challenged. One of the biggest is the realization by many that there is now a hugely reduced need for many to travel to a fixed place of work every day. During the pandemic, a large proportion of office-based roles were able to transition to working from home. There are many reasons why individuals may wish to return to the office, and there's been pushback by some employers regarding staff not being physically present. But the use of agile working practices will inevitably be much higher than a couple of years ago. The exact levels vary enormously according to business sector and organisation attitudes, but recent figures are indicating at least a third of office-based roles continuing to work from home on an averaged daily basis. How this will translate to demand for services by commuters is still open for debate. But it is clear that there will continue to be a requirement for people to go to a fixed workplace, even if many only do this on a weekly or monthly basis. We will therefore need to ensure that workers are able to commute in as safe and efficient manner as possible. One of the biggest tenets of local authorities to overcome congestion has been to encourage travellers to use public transport in and around our cities. Passenger numbers on our railways have increased year on year, taking commuters in and out of our cities, and buses, trams and underground services provide effective means to transport the public within urban areas. During the social distancing era, many users looked for alternative modes instead of public transport, which avoided close proximity with others. Although this resulted in many returning to use private vehicles, there's also been an upsurge in active transport modes. As the situation normalizes, it is expected that the increasing numbers of commuters will result in the need to increase the capacity of public transport and active transport modes instead of prioritizing private vehicles. It's obvious then that the existing design of our city centres will need to be reviewed in order to cater for this change. Across most cities in the UK, traffic systems make use of extensive sophisticated vehicle detection equipment to optimise the operation of traffic signals across a city. The vehicle detection infrastructure will typically gather data in real time on the numbers of vehicles leaving each set of traffic signals, so that the traffic system knows how many vehicles will arrive at the next set of signals. In this way, it is possible using the urban traffic control, UTC for short, systems to constantly optimize the operation of the signal infrastructure to adapt to current traffic demands. Most cities use a UTC system called Scoot here in the UK, which achieves this adaptive form of operation. However, when it comes to the way in which pedestrians and cyclists interact with these systems, it has generally been fairly rudimentary. Currently, most traffic systems across the world only use crude presence detection for pedestrians and cyclists. At signalised pedestrian crossings, a pedestrian push button is used to register that a user wishes to cross. However, this is a simple input which does not include any other parameters, such as the number of times the button has been pressed. So no, it doesn't matter if you keep pressing the button, it doesn't make any difference. The system therefore does not have data regarding the level of current pedestrian demand, let alone any ability to plan for anticipated use in the following minutes. In a similar vein, where specialist cyclist detection is provided at traffic signals, usually only on segregated cycle approaches, these will only register that there is a cycle present, and it doesn't account for the level of demand. The technologies exist to capture the data, using a range of tracking radar and thermal imaging to actively identify non-motorized users from a background of other modes of transport. These can then provide real-time data sets that include effective classification, count, and even trajectory.
Please remember to like and subscribe to keep updated with ITS Now.
What is really missing at the moment is flow data for these sets of users. So in a similar way in which Scoot provides information about the number of vehicles about to arrive at the next set of signals, we could start to use data regarding situations such as the number of people leaving a railway, tube, bus station currently, or who are walking from one set of signals to the next. Network journey time information for vehicular traffic often uses automatic number plate recognition, ANPR for short. This technology provides current journey time information from one node, a set of signals, a junction, to the next. And surprisingly, this type of approach can also be used for non-motorized users, NMUs for short. And no, we're not going to put bolts number plates to pedestrians. To achieve this, it's possible to use the unique Bluetooth and Wi-Fi identifying numbers of people's personal devices to monitor flow conditions of passing users. These types of systems are already widely used to monitor movement in locations like airports and large shopping malls, and can provide detailed information such as the journey time taken from getting off a plane, walking through an airport through immigration, baggage reclaim, the amount of time people hang around in certain areas of the duty-free area, and even if it's all synced in to the onward journey via transit to downtown areas. In addition, video analytics and artificial intelligence is now increasingly being used to provide much more insight to NMUs, their behavior and their requirements, although the way in which these can influence the operation of existing Scoot systems will need to be developed. The Scoot kernel did have an item added to it some years ago to make use of a measurement of pedestrian demand to adjust the operation of crossing facilities. This uses quite a crude volumetric approximation of the number of people waiting to use a crossing, but is the sort of feature which will need to be used more extensively to alter the level of priority and crossing time provision for pedestrian movements. Many modern signalized puffin type crossings also already have detectors to alter timings in response to pedestrians' progress on the crossing. So this may be an opportunity to review the pre-programmed timings associated with these facilities to further heighten the priority of NMUs over vehicular traffic. Interestingly, though, these devices can't be used with countdown timer type crossings, so those typically seen in places like central London, where the timings are set and are not able to be adjusted. As far as traffic signals themselves are concerned, these types of requirements are achievable now. Each traffic signal controller uses a site-specific software configuration, the program within the actual box, to operate it. And these can be altered to update the required method of operation achieved at individual sites, to tailor their operation and to work with additional equipment. A simple but very effective benefit can also be achieved by prioritizing signal stages for NMUs. Traditionally, traffic signals are reverted to the main vehicular stage if no demands currently exist at a site. But trials to rest on the pedestrian stages instead have shown a range of benefits with negligible impact for vehicular traffic. Therefore, this reprioritization of users should not only ensure NMU facilities are provided, but also encompass the inner workings of the signal operation as well. By use of these types of detection technologies in urban areas, it will be possible to not only monitor NMUs in the streets, but also to follow these streams of users through their entire journey, including at bus stops, within transit interchanges such as bus and railway stations, and onward to large offices or attractor destinations such as shopping malls. By using these data sets, it will be possible to not only react to current overcrowding issues, but to also undertake analysis to predict future issues as footfall increases over time. Reactive interventions could include a broad range of features, not only changing signal timings at crossings, but also disseminating travel information to users via apps and on-street display signs. This would be very important when services do not run as planned, so that users can seek alternative routes or revert to working from home or making the trip another day. It might also be possible to allow transit companies to increase service frequency dynamically to cater for numbers of passengers. Proactive interventions are also likely to be required for commuters to pre-book seats on public transport to avoid long queues and the increased journey times that are likely as a result. A substantial investment boost from central government has been used to assist in achieving this. However, this fails to make up for the lack of capital expenditure on traffic systems during the austerity era and will not allow local authorities to fully undertake equipment renewals to facilitate the modal shift desires of central government. These types of interventions will also support major environmental improvements to be supported and to maintain the temporary benefits that occurred during the pandemic, with reduced emissions and improved air and water quality being realized very quickly in many cities. There is a real opportunity to regain public urban space away from mixed traffic use to support the greening of our urban environment. Without such a movement, the result is likely to be a worsening of congestion on our roads, a situation even worse than before COVID-19. In addition to reapportioning capacity in our city streets by building good quality, dedicated facilities for public transport and active travel modes, the capabilities of the urban traffic control systems we use to manage traffic flow need to be augmented to provide capabilities which are similar to the detection facilities used for vehicular traffic, in order to minimise congestion for pedestrians and cyclists. Okay, if you haven't already done so, please don't forget to subscribe to our channel. Thank you to everyone who's done so far. Until then, see you next time.